Find the area of the triangle in the figure. So if I want to find the area of a triangle, I have to recall the area formula, which is the area equals base of the triangle times the height of the triangle, and you take that result and divide it by 2. So if I want to use this formula, I need to know the base and the height. So if I look at this picture, we have 1, 2, 3, 4, 5 segments, where 2 of them are dashed line segments. So I have to recall that the solid line segments are what represent the actual triangle. So if I were to recreate that triangle, it looks something like this. Doesn't have to be perfect. These are the different sides of the triangle. And I can see here, if I look at the picture, there's a 90-degree angle here. And I could recall that the base and the height of your triangle needs to form a 90-degree angle. Now if you look at this picture, these dashed lines are here because the vertex, you can see the vertex of our triangle is not directly above this side of the triangle. So this vertex is basically going to be dropping straight down here. It's on the outside, so the height is on the outside of the triangle. So if I drop that straight down, I would get that line segment. And since this is what I'm considering to be the base, if I need to extend it, since this is on the outside of the triangle, or in other words, this vertex is not directly above this base, so I have to extend this side. So I extend it, and you can see here now we have a 90-degree angle. And this 90-degree angle lets me know that this is the height if I'm considering this side to be the base. So sometimes we may be used to a triangle that looks like this, where we have our base and the vertex, if I drop it straight down, is going to be on the same side of the triangle, or the base of the triangle. But you notice here the vertex is not directly above this side. So that's why this one might not look like something that you usually see. So since this is going to be perpendicular to this side, then I know my base and the height. I can identify those. So for this, I'm going to substitute, what is the base? Well, the base is going to be one side of the triangle. So remember, the dashed lines are not the actual size of the triangle. So if I look at this, this is what my base is from here to here. And from here to here, I can see is represented by 6x. That's the distance from here to here. So I know the base of this triangle is 6x. And all this 2 is letting us know is that the vertex, if I drop it straight down, it basically comes out 2 units away from this vertex. But we're not going to include this in the base because the base is a side of the triangle, which is this side here, and that has length 6x. So this is the base. We're going to substitute that in at 6x. And then the height is going to be perpendicular to that side. So remember, this dashed line means we have to extend it a little bit further out because the vertex is not directly above this side. So that's why our height is going to be on the outside of our triangle. And if I look at this original image, when I drop straight down, the length of this side is represented by 4x. So the height of this triangle, we're going to put 4x. And if I want to find the area, notice we don't know the value of x, so our answer is going to be an expression. So I say a equals, and I'm going to multiply the values in the numerator. 6 times 4, we get 24. X times x, I get x squared. And then that result is divided by 2. And then I could take it one step further and say 24 divided by 2 simplifies to just 12. And then we have the x squared term. So our area is 12x squared. And we don't have an actual numeric answer because all the sides were represented as expressions and they never told us the actual value of x. So the area of our triangle is simply 12x squared.